Conditional probability. What is conditional probability? Conditional probability is when, instead of just figuring out the probability of some occurrence, you figure out the probability of a subset of events where some second event has already occurred. Now, of course, that doesn't make any sense anyway. So let's look at an example. First of all, the notation that we use for this. You're probably familiar with the notation like this that says P of E, which means the probability of some event we can call E occurring. This notation is read as the probability of E given F. See the slash between them? It's almost like a fraction. So the probability of E given F means the probability of event E occurring given that event F has already occurred. Now, why would this matter? Well, suppose you're trying to figure out the likelihood that some particular day in the future it might rain. You're trying to figure out what day to schedule your wedding or any big outdoor event. So it's too early by far to get a forecast. So the best you can do initially would be to just figure out the probability of rain occurring on any individual day. About the only thing there you could do is figure out how many days a year it rains and then divide that by 365. But suppose you want to get married in June, and where you happen to be, June has a different amount of rain in it than perhaps April or September. Maybe you could narrow it down to the likelihood of it raining any particular day in June. And you find out that in June, maybe it's likely to rain 5 out of 30 days, whereas out of the whole given year, it's likely to rain a different amount. So narrowing it down by something like the month of June helps to narrow down what the probability is. What if we were looking at the probability of it raining on any random day as opposed to the probability of it raining on a day that it's really cold and nasty and cloudy? That makes a difference, right? So let's take a look at some examples and see where we're going with this. Assume that 2 fair dice are rolled. Now, all they mean by fair dice is that it's just as likely to land on any one face. It's not a weighted die, you know, the cheating kind. So we've got 2 dice we're going to roll, and we want to compute first P of F and then P of F given E. Explain why the probability of F might change as it did when we added the condition that E had occurred. So F, the event F is that the total is 5. So here we have a chart. This represents whatever the first die lands on, and this represents whatever the second die lands on. And normally, when we toss a couple of dice, we're going to add the 2 faces together. So a 1 and a 1 would give us a 2. A 2 and a 1 would give us a 3, 4, 5, etc. 2 and 1 would be 3, 4, 5, and so on. So the 2 and the 6 over here would give us an 8. This one would be a 4 plus a 3 would be a 7, and so on. So if the total is 5, okay, we got a 5 right here. So here's a 5, here's a 5, here's a 5, here's a 5. So it appears there are 4 ways that we can roll a 5, a 4 and a 1, a 2 and a 3, a 3 and a 2, or a 1 and a 4, right? So the probability of rolling a 5 is 4 out of, there's a total of 6 by 6 is 36 squares, and 4 out of 36 reduces down to 1/9. But now event E narrows it down so that we're saying that event E is that there is an odd total showing on the dice. Okay, so we already know it's not a 2, it's not a 4, it's not a 6, this would be a 6, and so on. That's going to knock out half of these. See that? Out of all the possibilities when you roll 2 dice, out of the 36 possibilities, 6 and 6, 12 here, 1/2 of those are odd numbers and 1/2 are even numbers, which makes sense. So we have now narrowed it down to where somebody peeked and told us that the number showing on the dice for the total is an odd number. Okay, that doesn't knock out the possibility of it being 5. If it said an even number, now the probability of rolling a 5 is 0. If it says it's an odd number, then that reduces it down from 4 out of 36 to 4 out of 18, half of 36. 4 out of 18 reduces to 2/9. So the probability that we get a 5, given that it's odd, is going to be 2/9. Make sense? Let's look at another one. We're drawing a single card from a standard 52 card deck. Find the following probability. The probability that it's an ace, given that it is a non-face card. Now your face cards, those are the Jack, Queen, and King. And these 3 cards show up in all 4 suits. So we've got a Jack, Queen, and King times 4 suits. That's 12 cards. Out of the 52 cards, if 12 of them are face cards, then we know that 52 minus the 12 is going to leave us 40 non-face cards. So the probability of getting an ace out of these 40 cards, as opposed to the original 52. Now, originally, the probability of getting an ace would have been 4 aces out of 52 cards, which should be 1 out of 13. The probability of getting an ace, given that it is a non-face card, there's still 4 aces, but now we're only talking about 40 of the cards that could have possibly been drawn. So now the probability has gone from 1 out of 13 to 1 out of 10. Let's look at this one. What do we got going on here? You are to randomly pick one disc from a bag that contains the discs shown below. So we've got a pink one with a face and a blue one with a heart and so on. Find the probability that it's a face given that it's blue. The probability of picking a disc with a face given that the disc is blue. Okay, originally 4 of them have faces out of 10 cards. So originally just the probability of drawing a face out of all 10 would be 4 out of 10 or 2/5. The probability of getting a face given that it's blue, now we're only looking at the blue card, the blue discs. How many blue discs have we got to look at? 1, 2, 3. How many faces are there? 1. So the probability of getting a face, given that it is a blue disc, is going to be 1/3. Doing a conditional probability may increase the probability, but it may not. The probability now simply depends on nothing but how many faces show up in the blue discs. So it could have been that all of the faces were something other than blue. It could have been that all of the faces were blue. It would change the probability, but it wouldn't necessarily increase it or decrease it. So once you understand the notation here, it's really not going to be that hard. Let me know if you have any trouble with it, and I will talk to you later. Bye.